Hi everyone, this is Sharan. Welcome to my channel. Today is the final day of visualization using Python. So far we have covered all the basic charts using Matplot library. We have seen how to print various charts, how to do some customization, and how to make some changes in order to make it more intuitive. So today we are going to see about the Seaborn library. So the Seaborn library is as such built on top of Matplot library. So this is kind of a boiler template, which the default templates is much more attractive, and it allows us to make some charts with like just one line of code. The downside is it doesn't allow much customization, and often the Seaborn package or library might lead us to memory issues when we are trying to have multiple plots together when the dataset is really huge. So there are some memory issues that could come up when you use this particular package, but as such it is really useful when we are going to do the exploratory data analysis phase, because we would be making like lots of analysis, and the visual representation is better because it's very intuitive. It brings out all those insights out of the data, and Seaborn package would be very handy because it doesn't require much customization or much it doesn't require us to type in like multiple lines of code. With just a single line with two or more variables, we can pass it on, and then we can make a good attractive plot and then see the trend or see the patterns in it. So it's very quick, and dirty analysis can be done using the Seaborn package. And finally, we will see Bokeh and library that is used in order to build an interactive charts. So what would happen is the chart that we try to print will come up in a browser, which allows the browser to zoom in, zoom out, and make some change, make some like get into the details, see the patterns, and yeah, and so on. And it also allows the user to download the chart as an image. And that's it for today. We will get into the tutorial and go through the details, and we will see how to implement all these charts. So if you liked this video, if you like this series, please give a thumbs up and subscribe to this channel for some more similar content. And now let's get into the tutorial. As seen in the introduction, these are some of the advantages of the Seaborn package. So we can see that it's built on top of Matplot library. It is kind of a boiler template, like default streams are very attractive. And of course it has some downsides like memory issues. Let's go into the details. Let's import all the packages that is required for us today. So it would be pandas in order, because we are going to read the data from an CSV file, and then NumPy, Matplot library, Seaborn, as well as we are going to use a theme, the dark grid theme for today. There are multiple styles, like you can check out the styles and then see which one matches with your taste as well as the requirements of the analysis, and depending on that you can choose the particular style. So after importing all the required packages, so now we are going to get into the data. So the data set that we are going to use today is slightly different from what we have used so far. So the data set that we are going to use today is about heart failure, clinical data. So let me show you how the data looks like. So if you see here, so these are all the patients with an heart failure, a heart issue, and how many of them survived and how many of them did not survive. And it has various details like the age of the patient, like whether they were anemic or not, whether they had diabetes or not, about the blood pressure, and so on. So we are going to make use some of these data set in order to learn how the Seaborn package can be used to plot various charts. So for the line chart, what I'm going to do is I'm just going to fetch the age, the death event, as well as the number of patients in those categories. So let me execute this and then show you how the data would look like. So this is how the data would look like. It as we have age, the death event. 0 means the patient survived, and 1 is patient did not survive, and the count of number of patients in each of those categories. So in case of Matplot library, we would have seen that in order to do a trend chart, like for example, like we have seen like number of movies as well as number of TV shows, we wanted, like we had them as separate columns. So then only we can make use of Matplot library in order to plot all those series. Whereas in this case, we can see that the data is present in just one column, like both patients survived as well as did not survive is present in one column. It is not pivoted, unlike what we did for Matplot library, and we have the count in the other column. So this particular column that I am highlighting here, the death event, so this could be any categorical data. So this could have more categories too, and still like we should be, the Seaborn package should be able to plot multiple trend lines for each one of them. So let me show you like how an simple trend chart would look like. So let me execute this. So as you see, it's pretty much, it's just one line of code. I've just made a new line in order to, it becomes like more easier, or so that I need not to scroll to the right. So we can see that I'm just passing on the parameters like age, and then the count, that's the other axis. And then what I'm saying is, I'm saying the hue should be the death event, which means that this is an categorical data, and depending upon the value, it needs to be like a different color code needs to be specified. And what I'm giving is, I'm giving an aspect ratio, like how big the chart should be. So even without using the aspect ratio, the default the size should be good enough. And then I'm saying that the kind is a line chart that I'm looking at, as well as this is what the data is. So as you see, it's very simple. By default, it comes up with the name to the axis. So what it is doing is, it is picking up the name of the columns that we are passing as input, and it's able to print all those values. So it says this is the count, this is the age, and it says like it has two categories, two trends. Like one is patient who survived and who did not survive. So as you see, like with just one line of code, we are able to do so much. So this will be very useful when we are going to do the exploratory analysis, because we would be doing lots and lots of analysis to compare various attributes to bring out the patterns and trends in the data. And we can't spend too much of time in making a chart look better, or to make it more readable. So by using the Seaborn package, what happens is, with just one line of code, we are able to get what is required for us. Yeah, so this is really useful when we want to do a quick and dirty analysis. And the next one is moving on to the scatter plot. So again, it's one line of code. So what we are going to do is, we are going to pass on the different attributes. Like we are going to pass on the serum creatine as well as the ejection fraction. So I'm not someone with a medical background, but when I was reading about this particular data set, what I understood is, that the serum creatine as well as ejection fraction are two parameters that are sufficient enough in order to make a prediction on the probability of the patient's survival. So I thought, okay, this is a good example to pick up and then to plot and see the trend in it. So of course we are going to use hues to say that it's a death event, like it has data of patient who survived and who did not survive, and the kind is a scatter plot. So that's that, because we are going to print the scatter plot, and the data is the same data, and we have the aspect ratio to set the size and the aspect ratio for the chart that is going to come up. So when I execute this, so we can clearly see that it comes up with all the name of the axis as mentioned last time, and it says that the death event, like people who survived, is highlighted in blue, and then the who did not survive is 1. And we can see the pattern between the ejection fraction as well as serum creatine. So it seems that ejection fraction is like the amount of blood pumped out of the heart in a single beat. So it seems like the number generally for a healthy person, like it should be at least above 50. And of course, all these data are people with a specific heart condition, and hence the data is on like the lower end. And we can see that as we move towards the right hand side, where the serum creatine, as the number increases, looks like the probability of a patient not surviving is increasing. And we can see that when the serum creatine is low, as well as whenever the ejection fraction is quite high, we can see that survival probability is quite high. So I think this is able to, we are able to print out some of the patterns out of the data. So that's why we use the Seaborn package. So we want to do quick analysis. We don't want to spend too much time. We don't want to do type in multiple lines of code in order to make a chart look better while doing the analysis as such. So this will be we are able to, just in one line of code, we are able to pass on the values, and we are able to get the output and then see what's the trend in it. And moving on to the next one, so next one is still that we are going to stay with the scatter plot, but what we are going to do is, let's say we want to add an additional level of view on top of it. So let's say we want, out of all these patients, we want to understand how many of them are smoker and non-smoker. So then what we can do is we can make use of style, and then we can pass smoking. So smoking is an attribute in our data set. So if I go on to the top here, like I can show you. So smoking is also one of the attributes which is categorical at a 0 and 1. So I'm going to use bring that also into our scatter plot and then show you what's happening. So as you see here, what's happening is like the smokers are represented by X and non-smokers are represented by dot, and the color code of course remains same. So we can see that the probability of people not surviving increases if they are a smoker. That's something that is coming out here. And what we can also see is that we can see some of the patterns here. Like I guess for a smoker, the serum creatine, it most likely tends to shift to the right hand side. Maybe not exactly. Later there are a lot of people later, but the objective is all these parameters, like with just one additional parameter, we are able to bring in an additional point of view to the data set. So the purpose is that like we can make use of the Seaborn package in order to bring in all these kinds of different view in a really quick, like within a minute, we are able to get all these insights with a pretty good chart as well. And then we are not spending any time in giving the names or giving the names to the legend or formatting, specifying where it needs to be printed. By default, the template takes care of it. It says that okay, I will print the legend here and will give the name here and so on. So this is really good for the analysis. So the next one is a heat map. So heat map is really good in order to see some kind of a trend. So what we are going to do is we are going to see how to print and how to implement an heat map using Seaborn package. So in order to print the heat map, I'm going to slightly modify the data. I'm going to show you what I'm doing. So what I'm doing is I'm going to print the age of the patients as well as the ejection fraction, like the amount of blood pumped out of heart in a single beat. And what I'm doing is I'm doing the count on the death event. So which means that I'm going to print the number of people in this category. For example, patient of age 42 with an ejection fraction of 15, like one person died in this category, like in this group. So I'm going to print all the patients like who did not survive for this particular category. So now what I'm going to do is I'm going to use this exact data. So now as such, I'm not able to print out, or I'm not able to get any insight out of it, because it has so many numbers and it's impossible for us to see the pattern or extract the pattern out of it. But what happens is when I just use this one line of code, I'm passing on this entire data set, the data frame, and then I'm saying I'm going to print an heat map using the Seaborn package. So then you will see the magic. So we can see like that there are some globes that is coming up. The higher, so this is what the range is. So 3 is like number of people. So this is the number of people who did not survive. So we have a huge category, and this data set is quite small. I think maybe out of 300 patients, like close to maybe 100 did not survive, and the rest of the people survived. And the number of categories that we have is huge. So in any particular group, the maximum number of people who did not survive is 3. And then so this is how the color code would look like. So here we are able to see there are some flashpoints, there are something that's happening in the data, but still it's not very clear. So what we can use is with just few more modification, like by increasing the size and making few more changes, like not much line of code, just very few lines of code, you will see what's going to happen. Yeah, in some cases the Seaborn package would take some time, and as I said, it could go into memory issues like quite often then. But this data is not so big, so it should be fine. So in case that it's going to you are facing any memory issue, maybe try to generate a random subset and do the analysis. Okay, so as you see here, so now it's very clear. So we are able to see what's happening. We are able to see the age clearly, the ejection fraction, as well as we are able to see the numbers as well, like how many people did not survive in each of those strategies. So there seems to be quite a number of people who did not survive here in this group. So people of age group maybe between 60s and 70s and with a low ejection fraction. Yeah, so that's how like heat maps are useful. So heat maps are also useful when we want to plot across the time of the year, like over the 365 days we can plot on like various maybe if we have an hospital data, like number of patients coming into the hospital at various days of the year, and then see if there is any patterns. So this could be for anything, like for example customer churn or whatever analysis it may be. Like we can make use of the heat map in order to see whether there is a trend, whether there is something that is happening around in a specific segment. So that's when so heat map is mostly popular in time series data because it helps in just bringing out the patterns or seasonalities in the data. So in this case, I have used two different categories like age and ejection fraction, and then I try to bring up the heat map to show some of the patterns to you. Yeah, but you can feel free to make use of an time series data and then try the heat map and see what's happening, like how the trend is looking. So the next advantage is on the Seaborn package is the pair plot. So when we have a lot of attributes and then with just one line of code, let's say I want to compare each and every attribute with all the other attributes, I can use the pair plot. So what would happen is, let me execute this. It would take some time. So this is the data set that I'm going to use. I'm just selecting few columns from the data set, and then let me show you like how the output would look like. So what would happen is by using pair plot, so this is how it looks like. So it takes one parameter, like for example, like one attribute, age, and then it compares age with all the other attributes, like age with anemia, age with creatine, and age with diabetes, and so on. So what's happening is, so I'm just using a subset of it because like in the original data that we had 13 columns. So if I'm going to use the original data set, like it's going to take much longer time, as well as it's going to be so big that it might not be very clear. So maybe you can feel free to make use of the original data set and then use the pair plot to see how the trend is. So this helps us, like just with one line of code, it helps us to get the patterns of almost all the attributes, like which attributes are highly related to each other and not. Of course, we can make use of correlation and get a value about which is highly correlated and not. Whereas an visual representation is always best. We are able to clearly see the patterns from the data, like what's happening. So in cases where you are seeing like the data on the extremes, like it means that they are categorical data, so which is like 0 and 1. So if you are going to make use of this chart on a numerical data set, so this will be really useful. Like you should be able to clearly get some patterns out of it with just one line of code. So these are all the some of the charts or some of the implementation that can be done using the Seaborn packages. There are much more functionalities, maybe you can go through some of the functionalities like different sets of charts and then see how the implementation is. But in any of those cases, the number of lines wouldn't increase much because the template is kind of fixed, and then it's pretty much you need to pass on the values that is required as input, and then the output comes up. So that's about the Seaborn package. So the final one for today as well as for visualization is about like plotting and interactive plots. Like we are going to use Bokeh for this. So if you want to try this one, you need to install this particular package before executing this. So what I'm going to do is I'm just going to make use of age as well as the ejection fraction, and I'm going to just make a simple plot. So let me execute this one. So what would happen is, so this would create an output file, so named test.html. So this would be present in the folder here. So as you see here, the test.html is here. So this would bring up the output in an browser. So where we can zoom in, zoom out, and then we can it allows the user to even download it in like as an image. Uh, Download it as an image from the browser. So now we can see that it opens up in a browser, and we can see the age as well as each fraction and how the scatter plot is distributed. So there are few functionalities for zoom in and zoom out. So maybe for this data set those functionalities are not required, but there is an option to even save this as an image, and so on. So that's about the interactive plot. So we can it offers some more additional functionalities, uh, that allows the user to interact with the actual chart. So this is kind of like having a dashboard tool, and allowing the user to play around with the data. So here we are not allowing the user to exactly play around or make some changes, but we are providing the access or providing the insights directly to the end user, who can zoom in, zoom out, and then who can see some patterns, who can look into the granular details of those patterns. Yeah, so that's it for today. So we have covered the various charts that can be implemented using the Seaborn package. So of course we have not covered like each and every single chart, but this should be good enough for you to go ahead and then learn about the other charts that can be implemented using Seaborn. In most cases it shouldn't be much longer than 2-3 lines of code, that provided you just pass on the data in the required format. And then we have also seen interactive charts, interactive plots, which is really helpful when you want to share an analysis to a business user or to a stakeholder. So where we can just download it and then share it with them. So they need not have Python or Jupyter Notebook installed. So they just need to open it in a browser, and then they would be able to see the patterns from the data or whatever insights that we are sharing with them. So that's it about visualization. I hope you have learned something new today. So if you have learned something new, please give a thumbs up and subscribe for more similar content. If you think any of your friend is trying to learn data science or interested in the data science or in visualization using Python, please share this video with them. And that's it for now. See you on the next session. See ya.